Hello guys, welcome back to Staad.Pro. Today is the part 6 of this 7-story building design. So in our last one, the part 5, if you have not watched part 5, go to part 5. When we finished our loading and load combination, we ran the analysis and there was an error, and that error is what I want us to solve and fix in this class. So the error was because of the way we modeled our curved beam. This is the curved beam here, the way we modeled it. So this curved beam have limitations. So we are about to discuss the limitations of this curved beam. So, but at this point, if you are yet to subscribe to my channel, I will beg you to just do that quickly. Hit the subscribe button, like this video, just like it. Nobody is asking you for the like, nobody is deducting money from. Just hit the like button. It helps me. It helps the video to go viral. YouTube will recommend this video to many people, to more people, if we have more likes on it. So just hit the like button, share with your friends, share with your colleagues in the office.
Okay, I also have an ultimate Staad.Pro tutorial which has pre-recorded videos for 12 days. To just take you 12 days to learn Staad.Pro. I packaged it and arranged it for just 12 days. Every day, each day has a particular video to it. So it's a pre-recorded video. So if you want to get that particular tutorial package, the link is in the description. Just click the description, follow the link, and get and procure it. It's not expensive. So as you are going through the training, you can also be contacting me on WhatsApp. My WhatsApp contact is also in the description, so that we have a seamless learning. So I will be with you. I will guide you. I have so many bonus packages included in that video. Like we designed the real life duplex. Everything about the duplex was designed. We also did a steel structure. The tutorial video the training covers both steel and concrete. Designing concrete with RCDC software, which is also part of Staad.Pro, but it's a different software, but embedded inside Staad.Pro. We also did foundation design. So it's not something you're going to miss. You don't want to miss it. If you want to be very strong and sound and build up your confidence in the usage of Staad.Pro, that course is for you. Just get it. I'm going to be with you. We're going to be talking. Even if you need the one-on-one discussion on a particular challenge you're having during the training, I'm always available. You can do a one-on-one. You can do it one-on-one. Through any means that we can find easy for us to use, be it a Google video or Teams meeting, or even if it is WhatsApp, anything. So just get it and we talk. Thank you very much.
So we are going to be discussing the limitations of curved beam that is gotten in this manner. So let me just display this curved beam in the way we will see it clearly. Click view. So I'll select this level and display that level symmetric. So this curved beam here, as it is here now, has limitations, and the way I modeled this curved beam, if you have watched the previous classes, the part 1 to the part 5, you will notice that the curved beam from this geometry, if you click on this add beam here, you see curved beam. So if you are modeling a beam, you are getting your curved beam using this icon. Note that this particular curved beam have limitations, like when you apply an area load or floor load, plate load, the curved beam doesn't take it. The only force, the only load that can be taken by curved beam is member load. That's any load with per meter, kilonewton per meter. That's the only load you can apply on curved beam. This curved beam here now cannot even take a nodal load, because we can't insert any node on this curved beam. Let's just look at it. As I have highlighted this node now, click on insert node. You see what they're telling me. Insert node facility is presently not available for curved members. So even if for example, if you want to apply another load on this anywhere along the curved beam, you see is impossible. You can't do that. So now let us look at the loads we have applied here so that we see what happens there. This is a floor load, the slab dead load. So look at what has happened here now. If you look closely, you see that the load is not extended to the curved beam. The curved beam is not taking it. So in the application, the software quietly avoided the curved beam. So it's not affecting it at all. So if you look at the distribution envelope, you see the portion is going to this place, this portion is going to that place. You see nothing is coming here. This one is like hanging. You get, so it's not affecting it. So it's not taking this load. That's why we had that error. So now there's a way forward. There is an option that we can explore, and that thing is you need to create node around this curve and use our normal add beam icon to create the curve. Simple. And that way the beam we have here will just be normal beams like others, and they will take loads, any type of load we apply on them, and we will have that error. You get, so we are going to practicalize it immediately. So we'll go back to model, then to the drawing. This is the drawing. This actual drawing we are using to demonstrate this. So if you are just bumping into this video, you have not been watching others, we have this actual drawing in the description box. So just hit the description box and download it. It's free of charge. I purposely attached it in the description because I wanted you to have this drawing so that you practice alongside with me. It is a live project. I'm actually designing this project for my clients. This drawing is what I collected from the architect, and my clients had already paid. So I'm using the actual drawing to develop my structural drawing. But before I arrive at structural drawing, I must have to do the design and analysis to develop a report. You understand? So when I'm done with my reporting, and I'll use my output from the report to develop the drawing. You get? But here in this channel, we're going to be doing the designing, yes. And I'll also show you how you can make your drawing very easy and fast. There's a software you can use, and once you just copy paste your Staad.Pro output drawings, and your drawings will just take shape based on the settings in the software. That's going to be in our subsequent classes. So just stay tuned and subscribe to my channel. So this architectural drawing, so we are going to, this is the set. So we need to create some nodes along this core and model it in our model in Staad.Pro. Then use normal beam to join the lines. So what I will quickly do is I'll click on this circle. I'm going to draw a circle here. So this is the node number 1. Of course, is already existing in the model. So I'm going to create more nodes here. So what do I do? I'll use the command called array. I will type array in AutoCAD. Say okay. Then from here, it's saying enter array type. So it's polar. Polar is circular. You have rectangular if you want it to be rectangular. So it's polar. It's circular. So the second one is the axis of rotation. So we look for the radius, the center of this arc. This is the center of the arc. I'll click on it, and I will say enter. So I have some points. I have one here and another one here. Then I have other ones here. I don't need these ones here. So I need more points along this line. So what I will do is I'll click on this one. This point has an arrow. So from here we can do modification. So I'll click on this and double click on this arrow. Sorry, double click. So when you double click, so I will put let me just put 20 here. say enter. So I have more points. So I'm going to use these points to, I'm going to model these nodes, So I have this one. This is already existing. So I'm going to model 1, 2, 3, 4. These 4 nodes. We already have a node in the model. So once I get these nodes on my model, I'm going to use a normal line to join them. So the more nodes you get will give you a more gentle arc. So that's another thing here. So when you create more nodes, you get more gentle arc. It's normal thing. So if you get few nodes, your arc is not going to be that gentle. It's not going to be that smooth. So what I will do now, I will get the coordinates of this point. So how do I do that? So I'm going to offset this node to this node. This is going to give me, this is the x dimension, and I will do for z 0.9. So I'm going to offset with coordinate of 0.45 in x direction. Is x, it's supposed to be x. I have my x to be here, my z to be this other side. So it's going to be 0.45 for x, 0.09 for z. So I'll come back here. So first thing I will do is to delete this arc. And then I'll select that node. Select node. Select this node. Ctrl C, Ctrl V. My x direction is going in the negative side of x. I'll put minus 0.45. Then z is going negative z direction as well. So minus 0.09. So let me confirm. 0.45 and 0.09, that's correct. I'll say okay. So that has given me the first node. Yes, so I'll go back again to get the second one. The second one will start from this one which I just established now to this point, 0.4 in x direction, 0.23 in z direction. So I'm going to do that immediately. Select node cursor, Ctrl C, Ctrl V. Minus 0.40 minus 0.40 minus 0.23. It's okay. That's the second point. So I will get the third one from this recently established point to the third one, x 0.31 0.34 3134. Ctrl C, Ctrl V. Minus 0.31 minus 0.34. If that's correct, 3134. Okay. That's the other one. So for the last one now, last one, x 0.19 z 0.42 1942. Ctrl C, Ctrl V. Minus 0.19 minus 0.42. That's correct. Say okay. Okay, this one is not aligned, so we will do we need to bring it outside a bit. Let me just try something out. Make this okay here, right? Control C, Control V. Let me try minus 0.3. And 0.3. Okay. Now better. So I will join them with here, here. Okay, we need to pull this one out small so that I can have a gentle arc. Okay, so select down with Ctrl C, Ctrl V. I'll go minus 0.1. 0.05. Let's try this. Okay, I think it's fine. So I will just add this. So let me clean the other ones. Delete this one. Make a node. So this is our arc. So we have succeeded in creating this arc with normal beam. So let us now go back to the loads and see whether if it has taken it. Yeah, exactly. You see the difference between that other arc beam and this other one. So when you create it with normal beam, you have problem in your loading, so it will affect the load, all types of loading. But when you use the special arc beam icon, this one, you are going to be having that error that we had last time. So what we are going to do now is to offset this member to the rest of the building. So but before that, let me quickly delete the other ones. So go to view, view everything, and delete this. Delete this. Now the end. Okay, I need to assign property to that beam before I start offsetting. So select. Let me assign property to it. Okay, so let me offset first, then assign property, because I can just remember that all the beams at every level don't have the same size. So if I assign property and offset, means I'll still need to go and change the sizes to align with, align with others. So let me just offset before assigning properties. So I will view. we'll select just the arc. Okay, let me show the structural shape diagram full section, so that I don't select the one that already have section properties. Exactly. That's good. That's good. So I can now view all the shape. We'll do translational repeat. I'm going to repeat it for how many levels? 1, 2, 3, 4, 5. 5. In right direction, number of steps 5. Default step spacing 2.6. That's the height of the building. Let's verify that 2.6. So we are not going to link step. Link step is okay. That's fine. We also do that for this one down here. Ctrl C, Ctrl V. We go minus 2.6. Yeah, that's fine. So we'll start the business of assigning property. Select view first. Select this one. Okay. So let's go to properties to know what property they have at this level. I'll select and assign the same property. So all of them now have the same property at that level. We'll go back to view. Let's select the second one. We'll do the same thing. Okay, select it. Okay, go to the third one. Okay, select assign. You have to make sure you assign to all the members, otherwise we have another error in our model and analysis. Okay. Vehicle structure. Okay. Just like this one. Assign. for next level. Okay, it has reduced here. This is the reason why I decided to do it one after the other. Now sign, view, post structure, select the next level. Okay. I'll sign. The whole structure. The last but not least, view, okay. Assign to selected beam. Okay, so we check the post structure. Let us read the trade day. Okay, so this is our beam, our curved beam now. So when we get to, the beautiful thing is when we go to RCDC for concrete design, RCDC designs this curved beam as one beam, even though it's broken into pieces, still designs it as one beam, sees it as one beam and designs it like that. So that's that. You don't think it's going to be designing it as pieces as it looks this model. So okay, we quickly go to our loading and see if everything is all right. We need to put our self weight, make it effective, take effect on the new members. So we click on assign to view. We don't have much work again. So this other one has aligned. If you need it has taken the loads. If you see here, see it has taken the loads, and that which is what we want. This one the same thing. Okay. We need to add the wall load on this place. Okay. Need to add wall load there. So what we do is go to view, view from top, view from top. I'm going to select this and assign the wall load on them. Okay, so let me view the whole structure and see if I have selected all of them. How beautiful. And I'll assign the wall load, assign to selected pin. That's beautiful. Okay, what else? The finishes, everything is now very okay. Wonderful. This one is good as well. the water tank load, the wind load, the other wind load. Yeah. So we are good to go. So we can now run analysis and check our design. So let's quickly run the analysis. We click on run. We have already put our analysis command. We have defined the command, so we just hit the analysis button. So at this point, I'll still beg you, if you are still enjoying this course and you know you have learned something, just subscribe, please subscribe, and like this video. Please. Okay, you see our analysis has gone through and is successful. We have 0 error, 0 warning. That's very wonderful. So last class, I think we had about 3 errors, and all of them centered on the type of beam, the type of circular beam we use, which wasn't taking our load. For us to be as safer side, we have also already learned that each time you have a circular beam or a curved beam involved in your structure, try to model it in a way that you use normal beam to, create the curve, not using the icon there as on the Staad.Pro. So just create it with normal beam so that you don't have issues. Yeah, so this is our analysis. So in our next class, analysis is successful. If you go to post-processing, you click on post-processing for you to see the output results, which is going to be the thing we'll be looking at for here in analysis, because this is a concrete building, is the analysis, the support reactions. Yeah, that's what is critical in analysis here. Support reaction. If it is steel, we are going to be doing the design, everything in Staad.Pro, and we see this utilization ratio and the rest of them. But because this is concrete, what we'll be getting from here is just the support reactions, maybe displacement values, support reaction displacement values, and the rest of them. So, but the member design, the slab designs, the column design, beam designs is done with this advanced concrete design, RCDC. That's what is called RCDC. Like in the introductory part, I told you that we are going to be doing concrete design with RCDC, which is a software on its own, owned by Bentley as well, but it is embedded in this Staad.Pro. Same thing with this foundation design. Foundation is also a standalone app or software, but is embedded in the Staad.Pro itself. So when you finish your analysis, you want to do foundation design, you just hit this foundation design icon here. It takes you to that software, and you do your settings, you do your design analysis and foundation design. Same thing with RCDC. So like in our next class now, of course we are done with analysis. We'll go to this advanced concrete design and design our slab, our beams, and our columns. With RCDC you can as well design foundation. Yes, you can design foundation as well. But next class we are going to be designing slab. But before then, let's just look at the post-processing, the data we have inside there. So when you click on post-processing, it brings out this primary loads and load combination. So what I usually do is I remove the primary loads. So the output I will be seeing in my post-processing will be based on the load combination. So this load combination from serviceability to structural combination. So I'll click OK. So this is our displacements. You can see the displacement values, displacement summary. You can go to summary. The displacement. This is in y direction 12 mm is within the limits. Displacement shouldn't be 25, 30, 40, 50 is maximum. 50 is maximum in y direction. So what here we are seeing 12 as maximum. Yeah. So the displacement is in order. So now we go to reactions. That's support reaction. So when you go to support reaction summary, you can bring this thing out. Because we have plenty support there, we can as well bring all these things out to see where we have the maximum support. But maximum reaction, sorry. So but here we can just use this table. This table gives us the summary of the support and the load combination that is giving the maximum reaction. So here you see we have the maximum vertical force to be 2042. Because this is a 7-story building, we have it to be this 2000. Yeah, it's very big, very massive load. So the foundation of this building, it can be marked. Of course, it cannot be packed foundation. We can't use packed foundation for this. That you use mat or use pile. So we are going to explore it in this class, in this channel. Whichever one we are going to use, we are going to design it in this channel, either mat or pile. We are going to try the two. So now this is the maximum vertical force. This is maximum fx 43. So for my foundation design, I can use this information is very valid. So this is what we need from here. So if you need to move these things away from so that we can see clearly, you can move them, but there's no amount of moving that will make it look clear, because we have a lot of supports there. So if we have like 6 support positions, we can use this to move them to see where each particular support has all these things. But it's not bearable here. So we can just, this is the only option we have. So the load combination that gave us the maximum reaction is this one, load 19. That is the structural combination 402. So that's the one that gave us the vertical maximum vertical force. Yes. So we are going to stop here for today. So in our next class we do slab design. Stay tuned. We are going to use this RCDC to design that slab, and like I told you, I will be introducing to you a software that will help you fine-tune your drawings. Once you get your drawing from this RCDC designs a slab and details it. So when you are done with the detailing, you can just extract the detailing from the RCDC, save it as DXF file, take it to AutoCAD, and you now open this my software, which I will be introducing to you in our next class. And once you bring in the output of this RCDC into the software I'm going to be introducing to you, automatically the drawing will be fine-tuned for you automatically. You don't need to fine-tune much because it has already been programmed and all the necessary settings have been done. So once you just import it there, it does the work for you. You know what you're going to miss. I'm going to be introducing that. I have just for you to grab that. See you in the next class. Thank you very much.